Good morning all the colours of the rainbow. Well, grey and yellow. Yes, it's another Postbag. Now this one, interesting, or will it be as interesting as I'm hoping it will be? Let's find out. Envelope within an envelope. So let's open the envelope within an envelope. And I've got this. Now this could actually be just a repeat of something I've already got, but it might be intriguing. It's a repeat of something I've already got. You see, this is a 3-cell active cell balancer, one of these inductive cell balancers, where an overvoltage cell can distribute its energy to the two cells either side of it, even though they're in a series string, so they're all at different potentials. Quite clever. I bought a 4-cell. This one's a 4-cell. It has 3 modules and 5 wires. It's a bit confusing. This is the 3-cell. Now, the reason I bought this on eBay was initially it was advertised as a green PCB with the components not under this conformal coating. And I thought that might make it a bit easier to trace the circuit. We know what the circuit is now. We know what this chip is. If you go back to my previous video on this, someone located an article about it. Yeah, so I've just now got another 3-cell active cell balancer. Not a major issue. The other one, of course, is attached to my 3S supercapacitor bank. That's 3 lots of 2.5 volts, so 7.5 volts across here. Of course, there's nothing there at the moment. This will have discharged itself just really through self-discharge. Supercapacitors self-discharge much more quickly than lithium-ion cells. And in due course, I shall be attaching the 4-cell active balancer to my 4S lithium-ion battery pack, which is made up using these push-on Vroosened end caps. So that'll be coming soon. So this is the item I bought. It's a 3S to 10S to 17S lithium-ion LiFePO 4 LTO battery equalizer, BMS 1.2 amps. Yet to test that 1.2 amps. Now when I sort of purchased this, it had a different photo. I don't suppose that photo's still there. Oh, what's happened? What's happened there? No, we've got all these images. Let's go back. I'll cancel that. So they had one of these on a green PCB, which would have made shining a light through and tracing the tracks much easier. And it didn't look like it had any coating or sort of black stuff covering over the names of the components. But anyway, we don't really need that now. So this is a 3-cell, it's this little one here, and it was $8.50. Free shipping came from Liang. Now, in a similar vein, but perhaps not in a similar vein, we have this. Oh, it's pretty tiny. Let's have a closer look at it. So this is it. It's got 4 chips on there, 4 probably MOSFETs, and some low value resistors, although 430, that's 43 ohms, isn't it? Yeah. It's clearly something to do with lithium ion cells, because we've got 4.2, 8.4, 12.6 and 16.8. But what intrigued me was, what are these wiggly tracks for? What's that all about? This is not high frequency. This is DC, no frequency at all. And I presume it's just that the transistor puts that resistor across the cell. You can see there are 5 connections here, 4 elements. This is a 4-cell module. The description of this on eBay is really bizarre. It has nothing really to do with what this is. What I think this is a balancing module. So similar to the last one, but does it, of course, resistively. Doesn't attempt to transfer it from cell to neighboring cell. This just turns on a resistor. If one of these cell chips, these little 6-pin chips, detects that we're over voltage, presumably that's all it does. It does an over voltage check, turns on a resistor. But why the wiggly track? Bizarre. let's take a look at this on eBay and how it's just bizarrely misdescribed. So here it is. It's called a 4S 16.8 volt 100 amp BMS PC protection board, 18650 lithium-ion lithium battery cell. Now that's gibberish because it's not a protection board. It's actually a balancing board. And we'll go down to the description in a minute because it does get it a bit more accurate there. And what's 100 amps got to do with anything? No part of this circuit is capable of, I don't know, producing or accepting or tolerating 100 amps. It's absolute nonsense. But anyway, I thought it was an interesting board. $3.45, free shipping. Zibbanopper. Yeah. Let's take a look further down the page. And in the description, it says lithium battery balancing board. So it's a balancing board, not a protection board. Scope of application, 3.7 volts, nominal 4.2 full voltage, 18650, 26650 in polymers and all that sort of stuff. Balancing current is 100 milliamps, 43 ohms. Oh no, 43 ohms, sorry. 43 ohms, 4.2 volts. Yeah, that's 100 milliamps. Suitable for, well, that's a bit strange. But anyway, 100 milliamps is the balancing current. It's just a bleed current. It's a burning it off current. This product cannot be used instead of lithium battery protection board because it isn't a protection board. It's a balancing board. So why didn't they put that in the title? So all I can think is that, yes, that's 43 ohms, isn't it? All I can think is that this squiggly line could possibly behave as a fuse. But otherwise, I don't fully understand why that's there. Interesting nonetheless. If you're interested in what this chip is on here, it says BB3A. I believe it says BB3A. Anyway, it's an HY2213 one cell lithium battery charge balance IC, and I'll put a link to the datasheet in the description below. So the next one is this. Oh, that knife's really badly blunt. It can't cut through paper. I'm just going to have to tear it. Oh, what we got? Problems. Thank you. Thank you for your purchase. And, oh, what's this? Oh no, that looks right. Beautifully packed. Yeah, someone in the packing department must have been really bored. And so they decided to pack this extraordinarily beautifully in this sort of tessellated arrangement. I mean, why not just randomly shuffle them all up? Because let's face it, all they are 16 pin IDC connectors. Yay! So the purpose of these is to attach to my 16 wire ribbon cable, what I bought recently. Now this does have some connectors attached to it already. Now does it matter which way around these goes? Yes, I suppose it matters which way around they go that way, because that would completely reverse the direction. But you can rotate it so that the connector sits on the top of the wire, because this has to daisy chain some connectors together on the bottom of a load of boards, but one connector has to be added on the top of another row of boards at the bottom, if you get my meaning. I'll see if I can explain. So this is the board, whoops, this is the board that's going to have the connector sitting underneath. So it's a 2x8 IDC. That's going to sit under there, obviously soldered in. And that's going to take the single that's going to take all of the connectors, because there are 7 of these boards. They all sit next to each other. So there's going to be a daisy chain connecting all these boards together on the underside. But then there's this other board, which should have a matching position for the connector. Yes, it aligns like that. But this one sits on the top. So one of my connectors is going to have to be spun around 180 degrees and actually face, no, this will be sitting underneath like that, and this one will face downwards so that it can push down onto this board, and there'll be 7 connectors pushing up onto these boards where the ribbon cable connector sits on the underside. Essentially, that's how this is gonna work. And you can probably see on here that I've already started breaking tracks, because this board has some rearranged tracks. Because when I came to design this board, it was just so much easier and more logical to put the signals into different positions than I'd chosen when I designed this board, which was an earlier design. So they're going to all shuffle down to here, but I'm going to do those mods. I'm not going to attempt to scrape these and solder wires, because there'll be a connector on the top here. So I'm going to just put mod wires on the bottom. That's also been cut there because that has to go up to the top now. So yeah, this is all being modded for new positions. And I've got a funny feeling actually that this board is going to have to go to a Rev 2, because I think I've made a bit of an error. I haven't given this board any outputs. I'll go into this in more detail in another video, but yeah, this board needs a couple of 8-position dill pads for output RCAs, because I kind of mistakenly thought that I'd put the excitation signal from its preamp to the output and to the PPM, but no, it needs to be the entire mixed excitation signal with all of the stuff on this board that goes to the output board. So yeah, a couple more RCAs there, and that's not possible to do as a bodge. So I'm going to make a new board. It's going to be yellow. Now while I'm here, I might as well open this one, because it's kind of related, and it is very simply some 10-way ribbon cable, and I've ordered a load of 10-pin IDC connectors because this fits onto another IDC connector, which is here. So 8-way version of this will be soldered again on the underside of the board. That's why the silkscreen is on the underside. But what I've noticed, and this is going to be a problem, is that when these boards sit as they do 1/10 of an inch apart, which is about that, I've got 2 connectors which are bridged with a ribbon cable, but the ribbon cable daisy chains onto 14 of these things, but these are very close, and I don't know whether I can put a little loop in there or whether I'm going to have to go straight across, but I need to maintain this 1/10 of an inch to some degree of accuracy. So pressing the connectors onto the ribbon cable is going to have to be done with immense precision to get that cable to bridge across that gap and leave these boards at 1/10 of an inch. Maybe I could, well no, it's just going to be a case of getting this absolutely bang on. Now how do you fit your IDC connectors onto your ribbon cable? Well, it would be this ribbon cable. I've always done it using a vise. This one's seen a bit of outdoor action recently, so yeah, I just put the ribbon cable into the connector and crush it gently in the vise. Is that how you do it, or do you have a cunning plan that I haven't thought of to put IDCs on ribbon cable? Very interesting these things are. So this is 16 connectors. Now of course these are 1/10 of an inch apart, but there are 2 rows. These, there's a single row and they're 1/20 of an inch apart. How does that work? Well, let's have a look. Let's get this thing out of there. So you've got 2 rows of these jaws which cut through the insulation but don't cut through the metal, obviously. I'll get a magnifying glass. And they've got a little offset on them. So they're offset from the holes, the 2x8 row, so that they are staggered and positioned at a 1/20 of an inch spacing rather than a 1/10 of an inch. Now that means that you can put this up under the cable, or I can rotate it this way and put it down onto the cable, and it won't actually affect which pin gets connected to which of the cores of this cable. But yeah, that's how they convert 2 rows of 8 into 1 continuous row of 16 at half the pitch size. And they're little blades. I don't think they're particularly sharp, but they do push through. And I've got a feeling they don't open because they're held by little recesses in the top piece Let's have a look at the top piece. Yeah, so the jaws go into those recesses so they can't bend out, because they look like, as you put this on, they would bend out, but they can't. So that's how it works. So these are the ones what I bought. 20 pieces black, 2.54mm pitch, 2x8, 16 pin, IDC female header. $4.99 for those 20 pieces. Free shipping, beautifully packed, as we saw. Yixu 2010. This 10-way ribbon cable, 1 meter of 10-way, 1.27mm pitch, of course. Grey flat ribbon cable for 2.54mm dual row connectors. Free shipping, 99 cents. That's what I like to see. And I got this one from Satisfy Electronics. So that's all the ribbon cable-y, IDC connector-y sort of stuff. What else have I got that's quite interesting? Yes, how about this one? Interesting this. It's the only item I've ever had which has come from China, but I got an email from the Royal Mail saying an item from Frankie Tong, actually, is on its way to you. Well, how nice to be told. So this is the item, and this was a bit of a luxury purchase. Frankie Tong was the guy who, some time ago, sent me a few of those little USB power monitors, voltage and current and all that sort of stuff. And I saw he had this, and I just thought it was high time I got myself a nice new battery box. This one is screwed. A couple of wires coming out. I'll have to put some connectors on those. And an on-off switch. That's very nice. Let's take it apart. So you've seen me use this a lot. 4 AAs, which in nickel metal hydride fully charged give you really quite close to 5 volts. And this one I like to have the batteries on display because they just look pretty because they're all different colours. But the switch is on the bottom, and that means it doesn't quite sit flat on the table. It sits on its switch. And this switch, after numerous ons and offs, has become a little bit sort of scratchy, a bit graunchy, as I call it. So what I really wanted was one where the switch was on the top. And that's what I think this is. But it wasn't cheap. But I felt it was worthwhile. So let's hoik out these screws. Oh, are they in actual metal thread inserts? No, possibly not. Oh no, they're nuts on the back. I wonder if they'll fall out. No, they seem to be reasonably captive. And this one is actually waterproof. So when sea level rises to the height of High Wycombe, which is pretty high, I think, so it'd have to be quite a bit of sea level rise, I'm going to be fine. So now this one looks like it might be exactly what I was after. Something which will take my Eneloop cells like so, and where the switch is on the top. Oh, is that shorting? No. Oh, well, it won't matter because I haven't got all the batteries in. Switch is on the top, so no longer do I need to rummage underneath this thing, sliding that switch. I can have this sitting without its lid, with the batteries on display, and have my little on-off switch there like that. It'd be quite nice to have a little LED in there as well, wouldn't it? Perhaps I'll fashion one. The waterproof thing is not entirely necessary, but yeah, this is my new battery box. I'm very pleased with that. Just putting the remaining cells across into my new battery box. Now, I don't want to lose these screws. I don't want to lose the lid, really. So to not lose the screws, I can screw them in like this. Can I? Oh no, that goes down onto the bench. I just put little spacers in. Well, anyway, I can push these in far enough that they grip the nuts. Yeah, I'm making a bit of a meal of this, aren't I? But I love my new battery box. Let's have a look at it on eBay. Throw this old one away. It is a waterproof 4x AA 6 volt, or in my case about 5 volts, AA battery box. Case holder with cover and switch. Waterproof with cover and switch. And for me, more importantly, the switch is on the, well, top side, and you can leave the lid off and you can show off your nice, colourful batteries. So this was $5.19, but $3 shipping. That makes $8.19. And it came from FT2000, which is Frankie Tong's eBay. And so these are today's Postbag items. Now, a big thanks, as always, to my sponsor, JLC PCB, who do these sorts of lovely things. And a big thanks to my patrons, who help me buy these sort of things. So if you'd like to become a patron of this channel, you can click this link here. Another couple of videos up here if you want to watch more of my stuff. And if you're not subscribed and would like to be subscribed to my channel, you can click this link here. Cheerio.